the Mine Environment and Mineral Conservation Week celebrations in this region are convened. For 2 decades now, in the decade that went by, the mining industry in the state of Odisha has seen many transformations. A host of regimes towards sustainable development goals in the mining sector were set, and the industry is by now well acquainted with the goals. The object of competitions among the participating mines has also been gradually brought into the ambit of sustainable development framework. In this documentary, let us see the progress made by the mining industry in the state of Odisha during the last decade in the mining environment and mineral conservation subjects leading to the sustainable development goals. I appreciate all the participating mines for their enthusiasm and for their continuous efforts.
For many years, and in most parts of the world, mining was carried on with little regard for environmental protection, or for the health and safety of miners, or for the culture and well-being of local communities. However, this imagery is no longer accurate. Protection of the environment, of miners, and of nearby communities has become as much a concern as that of winning mineral itself. In the past decade, Sustainable Development Framework was formally adopted for the mining sector in India. Between 2014 and 2018, many new statutes to regulate the mining sector came into effect. The National Mineral Policy 2019 was also announced, and it forms the basis for mineral development in the country. The Indian Bureau of Mines has been convening the Mines Environment and Mineral Conservation Week for several years now. The motto of convening the MEMC Week by the Indian Bureau of Mines has been to propagate best practices of mines environment protection, mineral conservation, and peripheral community development. To be precise, propagation of sustainable development goals. The mines located in different regions of the country have been participating under different regional offices of the Indian Bureau of Mines. Bestowed with 97% chrome ore, 54% of bauxite ore, and 33% of iron ore of the country, Odisha has transformed itself into a highly industrial and progressed land. Having large mineral resources, Odisha is a top mineral producer. Contribution of mining sector to the state GVA is significantly high, making the industry sector's total contribution stable at 40% for the past 10 years. The mining sector in Odisha contributes 10.28% of the GSDP. The mining industry in Odisha has stood up to the legislative mandates and overall expectations during the decade that went by. The Mining Fraternity plays a key role in compensatory afforestation program that aims to bring back the forest in lieu of the degradation caused due to mining. Compensatory afforestation and barren area afforestation was initially started with fast-growing and less care-needing plant varieties. The Mining Fraternity has in the past decade put in a lot of effort to bring up a green cover consisting mainly of local species. Plantation of local species would merge with the natural green cover of the locality and spread fast. In addition to sourcing saplings from the State Forest Department, many mines developed their own nurseries and deployed dedicated manpower. During the decade, efforts to relocate grown trees of 10 to 15 years were also observed. One of the mines had introduced a tree transplanter machine specially developed for the purpose. This machine was capable of uprooting a grown tree without disturbing its soil around the tree. Soil of the radius of 3 feet and depth of 6 feet is plucked along with the tree and transplanted in another location. Survival rate of 1,000 such trees was reported to be about 95%. The practice, if continued and propagated, would certainly save 10 to 15 years of tree growing efforts. The state of Odisha has 1/3 of its land covered by forest. Even though the land covered under the mining operations in the state may be small compared to the forest area, the efforts that went into addition of forest cover has been significant. The afforestation program by the mining operators during the last 10 years has added approximately 36 lakh plants inside and outside the lease areas. The actual plantation number were 44 lakh 22,000 saplings. With an average survival rate of 80%, 36 lakh have survived and grown into trees. In the decade that went by, an area of about 920 hectare within the lease area is afforested by an average of 65 mines, and an area of about 2,364 hectare outside the lease area by an average of 25 mines. In most cases, the mineral being one makes up only a small part of the excavated material, which means the vast quantities of waste must be handled. Mines today manage waste dumps in a highly systematic manner, almost textbook style. Theoretical norms that were once considered difficult to practice are today some of the most established practices. Multi-level stacking of waste dumps, stabilization of dump slopes using coir matting, plantation through the bioabsorbable coir matting, construction of permanent concrete toe walls, maintaining garland drains having intermittent settling tanks are meticulously developed, and a mature level could be seen in the waste dump management among the mines in the state of Odisha. Mineral wealth is site-specific national wealth and is exhaustible as well as non-renewable. Therefore, conservation of the precious mineral resources is an essential part of the mine development cycle. For the purpose of mineral conservation, firstly, distinction between the ore and the waste is essential. The Indian Bureau of Mines therefore defines threshold value of minerals by percentage of their mineral content. The low-grade ore below the threshold value is considered the mining waste as distinct from utilizable fraction of ore zone. In the past decade, the mineral conservation aspect got a boost from great amounts of R&D. The mining industry exhibited its continuous commitment towards mineral conservation and value addition. Upgrading low-grade ore became more prevalent. Some mines introduced mobile mineral washing plants of about 120 tons per hour capacity. Some others established pelleting plants in order to make the low-grade fines a marketable product. Upgrading the low-grade ore by literally washing is called mineral beneficiation. Newer beneficiation methods were aimed at reduction of slime loss. Secondary feed of the slime generated during washing of the low-grade mineral yielded results. Thus, with the advancement in technology, many iron ore and chrome ore beneficiation plants have achieved a higher rate of mineral recovery. The primary idea behind all such measures has been to economically derive as much mineral as possible during the currency of mine development. Moreover, where the leases are contiguous, possibility of mineral being locked in the safety zone of both the mines at the common boundary wall is natural. If the mineral is left to remain till the end of the mine life, winning of mineral locked in the common boundary would certainly not be economical. Therefore, under legally binding agreements and with prior approval of the government, the mines on either side went for common boundary mining activities. Despite continuous efforts, both by the government and the mining industry, a huge amount of low-grade mineral finds have not found market and are lying at the mine sites. However, the mines have meticulously stacked this low-grade mineral, giving due importance to their future market. Active waste dumps and low-grade mineral stacks led their wash-offs to low-lying areas during monsoon. Water flow cannot be completely stopped, and therefore the water that flows can be controlled to the extent the silt is not totally carried away. In order to minimize the silt wash-offs to low-lying areas, many mines build series of settling ponds with weep holes. This helps in letting the water to settle a bit in one pond before overflowing to another pond. Water channels along the dump slopes came up to be a standard practice in multi-level waste dumps. Chromite mines necessarily need to treat the mine water before it is discharged outside the mine. The water from chrome ore mine contains hexavalent chromium, which is hazardous. Therefore, the hexavalent chromium is required to be reduced to trivalent chromium. Even though effluent treatment was in practice and monitored by the Indian Bureau of Mines, the chromite sector brought about lasting transformation in its mine water treatment. Technologically advanced, state-of-the-art automated ETPs in series have been built in each mine to meet the demands of effluent water management. Beneficiation of iron and chrome ore involves management of huge amounts of slush, mainly containing very fine mud particles. Huge tailing ponds were required to be maintained in order to let the slime to settle and sun dry. Separate measures were in practice to handle the water coming out of these ponds. In the past decade, many iron ore and chrome ore beneficiation plants were seen moving from traditional tailing ponds to filter press technology. The slime generated after washing of iron ore is fed to an array of membrane filter bags. The slime is dewatered by about 80 to 85%, and the semi-dry cakes squeezed between the membrane bags are conveyed to a stackyard like any waste dump. This material is rehandled after drying, which is only a matter of days. The water so squeezed is fed to a thickener. The overflow is again recycled while the underflow is fed to the membrane array. Using this technology, water is available for immediate recycling. One of the most important developments in the last decade was the adoption of fruitful rainwater harvesting methods. The rainwater harvesting was initially observed only in a handful of mines. But today, many mines have put in place huge rainwater harvesting ponds according to their water requirements. Aesthetics included, rainwater harvesting ponds are also developed into public parks. Further, groundwater recharge also saw a great push with these efforts. Drilling, blasting and excavation activities are primary to mining operations. But these activities release a lot of dust flying into the air. Besides, handling the excavated run-of mine by transportation, crushing and screening are also bound to release equal amounts of dust into the air. The Mining Fraternity in Odisha has been doing its best to adopt different methods to suppress the dust flying into the air. The past decades saw prevalent use of rock breakers that eliminated the need for secondary blasting of massive rocks, thus further minimizing dust due to blasting. The blast holes are required to be drilled for charging explosives and explode huge rocks. Earlier, this was a highly dust-prone activity, but newer machines with inbuilt dry fog system, dust suckers and bag filters came into operations. Today, drilling a blast hole is achieved with negligible amounts of dust, if at all any. Initially, the mine haul roads were sprinkled with water by using water tankers. Gradually, piped water sprinklers came into existence. The past decade witnessed almost every mine installing permanently fitted water sprinklers that run in timed intervals. In order to conserve water and to avoid soaking the ore, dry fog systems gradually became prevalent. This system used lesser water with high air pressure so that fine water particles could effectively catch dust particles and settle down. At the same time, the ore is also not soaked but only kept moist. This further prevented dust generation during transportation. The dry fog system was gradually deployed at every point where dust was expected to be generated. Later came the mist guns, further advanced standalone or truck-mountable equipment that shot moisture to longer distances. Lesser water was used similar to dry fog system, where the dry fog system has one or few nozzles, while the mist gun shoots moisture through several nozzles. The haul roads being a major source of dust generation, many mines deploy motor grader and water sprinkler combination to keep the haul roads smooth and dust suppressed. The use of public roads and highways for transportation of ore causes a lot of air pollution to all those localities that fall en route. Many mines are seen to have constructed their railway sidings right up to their mine site to transport ore by railway and thus reduce the load on public roads and highways. Apart from these, many mines develop their own environment monitoring stations and environment laboratories. Abundant measures have been put in place by many miners to monitor ambient air quality. In toto, the air inside a mining lease can be said to be cleaner than that outside the lease area. The public roads suffered due to spillage of ore by the overloaded trucks. It was a challenge to tackle at the mine level, but innovation had its way. The QDS, or the Quick Dispatch System, was developed at pilot level initially, and in the past decade, the system was quickly adopted and spread across the state. This is an improved version of the computerized weighbridge connected online to the Directorate of Mines. The land use pattern of the leaseholds during the life cycle of the mine leads to degradation of land as well as occupation of land by waste dumps. The current best practice dictates that all mines should be designed for closure. While progressing mine closure planning is an essential component of the mining plan or mining scheme for running mines, final mine closure planning is a statutory tool for partly surrendered or fully surrendered areas. In both the cases, reclamation and rehabilitation is mandated under the Mineral Conservation and Development Rules. Proper planning, therefore, is essential to reclaim the degraded land and suitably rehabilitate it. Over the years, it is observed that awareness towards reclamation and rehabilitation of the degraded land has come of age. While mined-out quarries are reclaimed by backfilling, stabilized dumps are reclaimed by spreading topsoil on the dump top and terraces. These reclaimed areas are suitably rehabilitated either by plantation or utilizing the areas for other purposes. Bauxite mines in Odisha are one of the biggest achievers of reclamation and rehabilitation. Bauxite is available in the intermediate subsurface. Unlike other metalliferous and non-metalliferous mines, the depth of bauxite excavation is relatively shallow. Therefore, the topsoil and overburden removed during the mining operations are backfilled immediately. Plantation of mines by these bauxite mines is the only forest created in the area. In the past decade, a total of about 1,075 hectares has been reclaimed and rehabilitated by an average of 53 working mines. The years 2014-15 and 2018-19 saw more than 75 mines taking up reclamation activities. Corporate social responsibility is no longer seen as a philanthropic activity. Developing the concept of corporate social responsibility in greater detail, supplemented by strong public opinion, is observed in the mining industry. Mining activities leave a lasting impact on the surrounding area and communities living there. Therefore, the CSR is largely seen as accountability of enterprises for their impact on society. Stakeholder engagement, social equity, and community relations are some of the issues that come into the ambit of CSR. During the past decade, many mines through their CSR program have laid sizable allocations towards water, sanitation, and medical care, besides education. Further, laying of blacktop roads and maintaining them is also one of the major CSR contributions.
ଏଠାରେ ମାଗଣାରେ ପୋଷାକ ଓ ବସ୍ତ୍ର ଦିଆଯାଉଛି ଓ ହଷ୍ଟେଲରେ ମଧ୍ୟ ମାଗଣାରେ ଖାଇବା ଓ ରହିବାର ସୁଯୋଗ ଦିଆଯାଉଛି ଓ ସକାଳ ଓ ସନ୍ଧ୍ୟାରେ ରିମିଡିଆଲ୍ କ୍ଲାସ୍ ମଧ୍ୟ ହେଉଛି।
नमस्कार मु मणि फ्रेटर्निटी आलुमिना बालिका उच्च विद्यालय नवम श्रेणी छात्री अटे। नाल्को जो अली अली झील योजना आरंभ करी सरकारी झील मानकर गरीब श्रेणीर मेधावी छात्र छात्री मानक यहाँ द्वारा समस्त छात्री योजना वर्ष को 6,000 टंका मिलूँ। यही योजना मत विगत 2 वर्ष हम मत मिली।
मोर नाम अमर चलान मु 9th क्लास छात्री एवं भितरगड़ ग्राम आसी
चाषरू बहुत लाभ पाइछु। आगामी दिन में कासुगुड़ार माँ मैंने समस्ते मिसी माछ चाष भी करने आगे बढ़ू आमर इच्छा अच्छी पनीपरिया करने आमर इच्छा अच्छी आम जमीक आर्थिक अवस्था भी आगे बढ़ी पारू आम जीवन जीविका भल हो।
नमस्कार मु अरविंद महांत घर पुरियाझर ये जो आप टेक्नोलोजी देखुं यार ना हूँ बायोफ्लक टार्गेट रखीचु जे आम 2टी टैंक रु 6 मासरे आम 1 टन रु अधिक माछ उत्पादन नापी ये सहित मु मोर निजर रोजगार क्षम हो पारि।
शरत चंद्र प्रधान ग्राम है काकुड़िया आम गाँव केते गुड़िया काम कर देखु आमर ये कम्युनिटी सेंटर तापर स्कूल घर रोसई घर स्कूल स्कूल पिला माने खायापी रोसई घर हो स्कूल बाउंड्री होपर पानीय जलर सब व्यवस्था कर स्वास्थ्य
घर कुसुमुंडिया मो एसएजी महापाट एसएजी रो मो प्रेसिडेंट अच्छी मो ना समस्त मोर नमस्कार मो ना निरुपमा देहुरी मो घर गुड़ीसाही आम संघर ना है।
With the hope that the coming decade will usher in much more glorious days in the story of Odisha's mining industry, let the endeavour be continued.